Hello everyone, welcome to this new class. We'll be working on building a traffic light project. So if you see right now, I'm just on my Tinkercad dashboard. I'm about to start a new project. So you come over to your circuit and then ignore the whole project you worked on. Just click on create new circuit to load up a new workspace for you to start tinkering and working with Arduino. Okay, so our workspace is open. Now you come over to your basic components, which we're working on for the most part of this course. So you just scroll down and then look for Arduino Uno R3 or version 3. So you just drag that into your workspace. Good. So next you drag in your breadboard small. So don't use a big breadboard so it will not take up the entire space, because the project working is actually small, so we need a small breadboard. Okay, so next we'll drag in an LED. Previously in our previous class we worked on blinky LED, so it's blinking our LED on and off. Instead of doing that, now we're working on traffic lights, which will be using three basic traffic lights, which is green, red, and yellow or amber color. So red, as you know, it's for stop. Amber, as you know, is for prepare or get ready, and then green is for you to go. So we'll just be simulating that same process into our project. But here I won't be using any timer, so you just be going sequentially. Now we drag in the red LED, put it on your breadboard. So note your cathode and your anode. It's very, very important. Now you are dragging your resistor. Please, first of all, let's rotate the resistor so it will be at a 180-degree angle. So come over to the top where you see the rotate function. Just click on it. Make sure your component is selected first, and then you start clicking on the rotate tool. It will rotate the particular component that is selected. Then when it's rotated at 180-degree angle, you just drag it and put one of the terminal of your resistor. It should be directly connected on the same roll at that particular anode of your LED. Sorry, on the same column with that cathode pin. Now it's time to connect our wires. If you discover on the Arduino Uno, there are three GND pins. So we don't want to make use of the entire GND pins. We just want to make use of one. So you can, unlike your digital and analog pins, your GND pins, you can connect all your projects into a single GND pins or a single power pin. For instance, if you want all your projects to be connected to 5 volts or 3.3 volts, you can wire all of them to be at that particular point. So by just using one wire to connect all of them in a series connection. So how do we do this? We'll get back to that shortly. But first, for our cathode column, we connect our jumper wires. Click on any of the empty holes to drag our jumper wires. Make sure it's connected on the same column of that cathode. Dragging your wire, you click on it to break, and then at the top of your breadboard, you discover that there's a minus line, and there's minus and plus at the top and bottom, just as you see. Those are your power rails. So we use the one at the top for now, or let's just use one at the bottom. So select this wire, delete it. So on an empty hole on the same column, drag a wire and then connect it to the minus rail on your breadboard at the bottom side of it. Okay, so you change the color of the wire to black because black signifies ground. Good. So now the other terminal of your resistor, you click on any of the empty holes connected on a particular column. Then you drag out your wire and connect it to a digital pin. So preferably, I'll be using digital pin 3. Good. And then changing the color of my jumper wire to red to signify power or data. So power or data. Okay. Now we'll move into the next LED, which is yellow or amber color. Dragging the LED, let's position it at the middle part of the breadboard to give it enough space. Okay, now we're dragging our resistor. Okay, so select the resistor and then let's rotate it to be at a one. Okay, make sure it's at a 180-degree. Then just similarly the way we connected the first one, just do the same for the second one. So we're dragging our resistor, connect one of the terminals to an empty hole on that particular column of our anode. Okay, now you click on the LED. Let's change the color of the LED. So you see the a little bit of dialog box here. You see color. So just click on red and then select yellow. Okay, so the color of the LED automatically changes when you select the color you want. Now, we forgot to do something initially when we started with the red LED. We have to change the resistance to be 220 ohms. So it's currently at 1 kilo ohms. It's too much. We will not see the LED blooming bright enough. So we change that to 220. Changes from k ohms and then just select ohms. Then we do the same thing for the other resistor. 220, change it from k ohms to ohms. Okay, now we continue the wiring part for the amber color LED. So any of the empty holes on the same column of the cathode, you drag out your wire. Okay, confusing now. Okay, let's just connect this directly. So you connect that to the minus rail on your breadboard. So there's a minus and plus rail, so connect it to the minus rail. Now you change the color of the wire to black because the minus rail is negative or ground. So black, that's what's the basic significance for that. So we connect the other wire on the second terminal of the resistor. So click on any of the empty holes, like note empty, click on an empty hole on the same column which is connected to this second terminal. So if you mistakenly click on any other hole that is not connected on the same terminal with the resistor, your product is not going to light up. So your connection is really, really important. So drag out the wire and connect it to digital pin, let's say digital pin 4. Then change the color of the wire to red. Good. So now let's do the same thing for the last LED. So you drag out another LED, give a little bit of space, change the color of the LED to, let me guess, green. Good. So it's time to drag out my resistor. Rotate it to 180 degrees. Change the resistance to 220 ohms. Sorry. All right, you drag that put the first terminal on the same column of the anode. Now let's do the connections. So for cathode, click on an empty hole, drag the wire to minus, change the color to black. Then for the second terminal of the resistor, drag an empty wire and connect that to digital pin 5. Then change the wire color to red. Okay, so now lastly, for all our connections to be all connected to the Arduino board, we will just click on any of the empty holes connected to the negative rail, because our project is not yet connected to ground on the Arduino, so there's no ground serving from the Arduino to the project. So to do that, you just need to take a wire from that minus rail of the breadboard and connect it to the GND on the Arduino. So to do that, you just click on any of the empty holes on the same roll. So you notice I was saying column, column, column since. No, now is roll. So on a particular roll, you have to click on any of the empty holes and drag out a wire. Make sure it's on the minus space, not the positive space. Drag out your wire and then connect it to any of the GND pins. It doesn't matter which one. Any of them is perfect. So you change the color to black. So we're done with the wiring for this traffic light project. It's time for us to start coding using C++. So what do? You simply go to code. You always see your blocks there, which is the first thing. So you just click on text to take you to your text. Okay, so you're seeing this empty text here. So for this, we are going to use some variables. Okay, so we're going to store all our pin numbers in a variable. So we already treated what are variables and other basic syntax in C++, Arduino C++ actually. So we'll be trying to enforce and emulate that in this project. So you just type in your int, which serves as integer, then the variable name. So we say LED red. Then we give it a value. We assign it a value by putting the equal to sign. And then we put 3, pin 3, because pin 3 is the pin that is allocated for red LED. Now we close that with a semicolon. Now for the next one, we say int LED yellow. So always capitalize the initial letter for the second word. Equal to, we assign a value to it. So equal to 4, because 4 is the pin we are using for the yellow color. So now the last one, which is the green. So the green LED is on pin 5. So always close your statement with a semicolon. If you don't do that, it's going to give you errors, because the program will think your code is still running. That means the statement still has other commands. For it to just close that statement, you just have to use a semicolon. So we declared all our variables and then we initialize the numbers, the pin numbers to them. So now let's move into the void setup and tell them that all our pin numbers are our output pins. So to do that, you just type in the built-in function pin mode, and then open your brackets, close your brackets, and also close. So inside the built-in functions, you type in your arguments. So So the arguments for this are just two. One, the pin number, and the second one will be the state of the pin. So you'd first of all put in the which number of the pin, pin 1 to 13, or from A0 to A5. And the second argument is going to be the state of the pin. Is it an input pin or is it an output pin? So those are just the two arguments it will take in. So we just, instead of using the numbers, we will use the variable names. So the first one is red LED. So give a comma just to tell the program that you are done with the first argument. So the second argument will now be the state of the pin. So this is an output pin because you're working with a digital pin. So do the same thing for the other pins. So you type in LED yellow. So it just automatically refers to whatever value is being stored inside that variable. So whenever you call the name, it will always give you that particular value inside the variable. So there's no need to always call the number, you just call the name. And whenever time you want to change the number or the value, you can just change that and it gets automatically changed everywhere you called that particular variable name. So outputs, because we are working with a digital pin, we are working with an LED. So the last one will now be pin mode. So you have to be sure of the names. You have to cross check your names, the variable names, and make sure it's correct. Because if it's not correct, the program will not work because it does not know, it does not recognize that value. It's going to give you an error because it does not recognize that particular variable name. So we are done giving all our variable names and then telling the computer what state of variable names we're using. So we are done with telling the computer a particular variable and what state do you want that variable to be on or the pin to be on. So now let's move into the loop. Okay, inside the loop, we'll write in the function called digital write. So it will write on the LED. So digital write, open brackets, no spaces, open bracket, close bracket, and close the statement with the semicolon. So inside the digital write function, you just type in the variable names. We put in, because the red LED always comes on first, so we put in the red LED first. Red LED, comma, high. So just like the P mode function, the digital write is also a function that takes in two arguments. So the first one is the pin number you're working with, and then the second one is to also change the state if you want it to come on or if you want it to go off. Okay, so for the red LED, you want it to come on, and then we'll now call another function which is the delay function, all on small letters, delay function, then passing the amount of time we want to delay. So for the red LED, it always stays the highest. So in real life application, when you're passing through a traffic light, the red color always stays the longest. Okay, so other road users can walk through the road. So the red LED stays the longest. So we're going to be simulating that particular feature here. So we're using 3000 milliseconds or 3 seconds for the red LED. Then we put digital white LED low to make our LED, make the LED low. Okay, so digital white, LED red low. So this will turn off the LED. So it's time for us to put in a delay. So it will stay low for 0.5 seconds. So it's just stay low for 500 milliseconds. That's 0.5 seconds. Okay, next we just do the same thing for the yellow and green LED. Okay, so I might not explain this much. Okay, so for the yellow LED, you want it to stay for a particular amount of time. It's not actually going to stay for so much time because the yellow LED is just get ready. So get ready doesn't take much time. So you're going to use just it's going to stay on for just 1 second. So that's 1000 milliseconds. So always note that you are always using milliseconds when you're using the delay function. Now it's time to turn it off. So when you turn it off, it's going to stay off for 0.5 seconds. So the next LED can come on. So just use 500 milliseconds. Now for the last one, which is the green LED. So if you notice what I'm doing, I'm just writing a comment. So it makes my code more readable for anybody to understand. You understand that the first one is the green, second one is the yellow, and the third one is the first one is red, second one is the yellow, and the third one is so digital right for my green, turn it on. So use LED green. We call the variable name and turn it on. So for the green LED, it doesn't stays at a more higher time frame as the red LED. So we're going to use just 2 seconds. So it's going to stay on for 2 seconds. So that's 2000 milliseconds. always add a semicolon after you've written a function or a particular statement. Then let's turn off the LED. So by using digital white, sorry, that will be low. Just to turn it off. Then add a delay so it will stay low for 500 milliseconds or 0.5 seconds. So we're done with the programming aspect of our project. It's time for us to start simulation. But first, we have to cross-check our code and make sure everything is working properly. Okay, I've already seen one bug in my program. So that's why it's always good to cross-check. So I think my program is now good to go. So what you just simply do is click on start simulation. So the error, let me just explain. The error that happened here was that I was calling a different variable name to come low. Okay, I was calling green LED to come low when it's not supposed to be green here. It's supposed to be yellow. So but I've corrected that anyways. So now it's going to work perfectly. So you just simply click on start simulation. When we clicked on start simulation, it gave us an error. So it happens. This will give us an opportunity to see how to debug our problem. So right here, you see a dialog box pop out at the bottom corner of your workspace. It's saying, sorry, it seems like your code has some errors. And then you see the particular space, the error you're having problem with. Right now, it's showing me on line 23. It says error. I spelled my digital incorrectly. So it's giving me a syntax error because it's coming out for me. I didn't type in the function name properly. So whenever you don't type your function name or your variable name properly, it's going to give you an error. For this is a built-in function, so it was built in by the Arduino community. So I don't need to create it all over again. I just need to call that function name and it's just appear because already on the Arduino, whenever you're downloading your Arduino, it's just there automatically because it's built in. It's already there for you to use. You just have to call it and use it. There are several built-in functions and there are several keywords. It's just calling the name and then the functionality is now accessible to you. So right here it's saying I didn't spell it properly and then it's now showing me the appropriate way to type it. So I just put in my I there on line 21. Okay, so on line 21. So it's in I. So I try to start my simulation over again and see if any error pops out. Okay, so luckily for me, there's no error, so it's working. So you see my red LED comes on first, yellow, and then green. So it goes over again, red, yellow, green. All right, so that's all for this project. See you guys in the next project. We'll be working with RGB LEDs.